Hello everybody, here's a little update. Just managed to make a jig up so I can basically show you what's going on. Basically, I have the solar power coming into the house via a Cat 5 cable. So it's probably not the best way of carrying a wire or current into the house, but it's the easiest way and it's less messy. If you see from the other videos when I use 4 wires, it looked rather a mess. At least this way it's, you know, a lot tidier. But anyway, they come into the house via these 4 cables. Each one of these coloured lot of cables is one solar panel. The idea is to get a board, put 8 screws in, so you'll have positive, negative of panel 1, panel 2, panel 3, panel 4. So I can quickly just change jumper leads, ones like these, and just say, right, well I want to run parallel, so I'll just run them off straight to the Leon charging circuit, and then these are attached to the battery packs. This keeps them charging parallel. In this bank at the moment I've got 20 cells and they're all 2.2 amp hours each. So probably about 50, something close to 50 amp hours per pack. I have 3 of these packs and they're all individual as it stands at the moment as charging. The idea is to keep them better balance charged by having a panel per battery bank. I have got a spare pack. I haven't got another 20 cells at the present moment, but when I do I'll be making this a 16 volt pack rather than the 11.1. The idea from there is they're running to the charging circuits. These keep the banks charged individually. The idea then is to take jumper cables just like this, join the positive of one pack to the negative of the next pack to produce a series pack. What then happens is this here, I finally found it, is the 3 series protection circuit. So basically you have a positive of 1, that's your main positive, and your main negative here. These 2 are for the 2 middle connections on the pack. What this does is it monitors each bank. If this bank drops to 2.5 volts, yet these are still 3 volts or above, it shuts off, stops giving you output of power. And it will not turn on again until you feed 12 volts into this unit, or you jump the positive battery lead to the positive power input, and then it will turn back on. So this is, it's probably not ideal, but it works and it stops you from over discharging your batteries. The solar power won't turn them back on again, so if this goes off while you're out, it won't be on again until you come home and basically reset it. But in this period it will have been topping up the batteries. Now the good thing is I've noticed is if these cells are higher than this bank, because this bank's lower voltage, there is a higher distance between the 4.2 volt and the actual battery pack's voltage, so the current is flowing higher. So where these at 3 volt will only be probably taking 500 milliamp, if this is 2.5, this will take closer to 1 amp until it balances out with the others. Now you might say that, right, well this is lower, it's never going to catch up. Well, because these are charging at a lower current rate, it allows this pack to catch up because it's taking higher current. So once it's balanced out, they will slowly, gradually start to balance out. At the moment I've only got a 10 watt to charge this bank, and this whole bank together I think was half a kilowatt of capacity. So it's quite a big pack, so 10 watt per bank takes a long time to charge. But because I'm stepping the voltage down rather than stepping it up, it uses less power. If my phone charging is only taking 1 amp, it will only take 1 amp out of a pack. Whereas when I was using this unit, which is just keeping my phone charged at the moment while I do this video, this unit here is a step up. It takes the voltage of a single Leon and takes it up to 5 volts. It also has a little circuitry needed to tell smartphones what current rate to charge at. So when this is in the unit, it will take 1.5 amps rather than a 1 amp your phone's actually charging with at a full flat battery. As the battery gets charged, just like these circuits, it starts to take less and less current to keep it going. I think that's all I've got explained for now. I will... Bloody hell. Okay, that stand may not work for holding a phone, but... well, back to the drawing board on that idea. But when I put it back together, this will be in the circuit. This will run off to this unit. This unit is one of the car step-down transformers that you get in the car for charging your phones. Basically, your positive goes on here, your negative will go here, and this will give you 2 USB ports. This, at the moment, will be to charge my phone and the LED lights that I use as a night light at the side of the bed. Being 5 volt, they should be a lot brighter. I was running them directly from the 3.7 volt pack, but now I'm going back to series again. That won't be any good anymore because it'll just blow the bulbs. Anyway, I hope that's explained enough. Sorry it's a bit higgledy-piggledy. I try to plan it in my head, but when it starts to come out my mouth, I lose flow and get confused. Anyway, any questions, ask away.